So operational amplifier and its applications. Operational amplifier. Okay. So content wise, when we have go to that one, it's a simply see that one. It's a OPAM. OPAM is a block diagram. It's a one of the famous, very oldest one. OPAM is a 741. So 741 and ideal and practical condition. You mean you are sitting on the meditation. Second one is you are doing the exercise. That is the difference between ideal and a practical. Then third one is a open loop and a closed loop configuration. Open loop and a closed loop configurations. Even your father is coming to the college regularly to check about your performance. So periodically your father is, so that is called a closed loop. So periodically he is coming and then checking your performance. That is a closed loop. So once it is once okay, put that mission, after that your father is not follow means, that is called open loop. Open loop means what will happen, sometime our desired output is may not achieve, mostly it is not achieving. So your father is setting the goals. Yes, my son should be son or daughter is getting the 85 percentage score, okay, overall score and distinction. So distinction and getting the placement and full-fledged to utilize the training sessions. So he's expecting that the expectation is a fulfill means closed loop systems. So you become a parents, so at the time you should be do as a closed loop systems. Okay, the next one is the application wise. So there are three application, you can say comparator, zero crossing detector. These two is a open loop system. Comparator and zero crossing detector is a open loop system. Segment trigger is called a closed loop system. That's all. Then after that, this is a small three topic. So last class very detailed I explained I to V and I to V and V to I converters. So why V to I converters? V to I converter means I want to transfer the information on the one long distance from college to the Kobargan. So hello, I want to communicate the information. If my voltage signal is sending long distance means at the end receiving end side, oh, only they were received O only. So I need, okay, they should receive full information. So hello, that one. So I want to use the converter V to I converter, then sending to long distance, then at the end of the receiver also they were received hello. So that is the purpose. I to V converter, what is the purpose? I to V converter, I to V means, okay, for a photovoltaic solar panel, that panel it is a current phenomena. Okay, the total entire day, okay, from morning 9 a.m. to evening 6 p.m. So hourly or that 30 minutes once my data is I need to measure the data. So if it is measure means, okay, current measurement, I mean current measurement available, current storage is not available. So DAC system available, that DAC system it will going to store with respect to voltage. So that's why I to V converter you can convert, and the voltage signal you can give to the DAC system. DAC system store. Then instrumentation amplifier, I said about that one. Okay, so it is a temperature in corona, that COVID pandemic situations. So everywhere it is they're testing the temperatures. So temperature, digital temperatures. Okay, touch. I mean they don't touch to that skin directly. So they will going to measure. They will going to check about the temperatures. So that is that instrumentation amplifiers. So they will going to physical quantity. Your temperature level is converted into the display. Okay, then peak detector means precision rectifiers, resistance values replaced into the capacitance value. I said the examples. So first years, you are for during the first years, okay, your father is giving the packet money is 50 rupees. Okay, he is taking first day, yes, you have 50 rupees. Okay, second day he's taking second day he's taking your packet amount is instead of the 50 you have only 40 rupees. So your father is giving 10 rupees. So that 50 rupees is sufficient to you can go from the home to the college and the college to the home, that is sufficient. So he will going to give, that is called a, so he will going to give that 50 rupees. So they like it is when you are moved into the second year, first year to second year. So your father is interested to increase your packet amount is 100 rupees. So 100 rupees where he will going to give, previously you are getting 150 rupees, now it is raised to the 100 rupees. So that's all. So these three examples you can keep it in your mind. So you will going to pick detector, it is a working. Okay, so let's we go ahead on that one first topic. So okay, what is that one general application of op-amp? So already I got touched. So even though I will going to revise, so amplifiers, so small signals. Okay, I will going to speak in front of the mic, but in the speaker it is amplified. How it is amplified? Because it will going to multiple with a gain, so that is amplifiers. Then active filters, so reduce that to some noise, okay, disturbances signals, okay, filtered, so noise. The next one, waveform generator. The op amp it is used to, you will going to generate the waveform. Next unit you will going to learn about that once. So here you will going to see something. Then voltage comparator, compare the two signals. So compare the two signal, voltage comparator, timer, and then regulator power supply, multi vibrator, precision rectifiers. So we were discussed. So these are the application is applicable on that op amp. The next one. So so block diagram of the op amp. So when you have see the block diagram of op amp, there are two input. So if I find, you have see that the symbols of op amp. So what is the symbols? So this is symbols of the op amp. So two input and a single output. Two input, single output, source plus VCC minus VCC. So this is op amp. So what is there inside? Inside there are okay two okay differential amplifier and one push pull amplifiers and shift registers. So that is there are four boxes there inside. The box number one is the okay input stage of that differential amplifier. So two input, that is a balanced output, 2L input, balanced output, two input and output is balanced. Okay, next one, intermediate stage. So it is unbalanced output. What is unbalanced? Two input and a single output, that is called unbalanced. The next one is a level shifter, shifting the levels. Okay, emitter follower used to control okay constant current sources. You will going to get the constant current sources. So like it is working on that one. Then output stage, what I am using, one push pull amplifier using. So next unit you will going to learn about the push pull amplifier. Simply I am say push pull amplifier, the efficiency is high. So like about that it's working. So this is a V plus, this is a V minus. So plus means it is a non-inverting input. What is non-inverting input? Whatever you are going to give, the same it is coming without phase shift. 1 minus 1, okay, uh, plus 1 minus 1 plus 1 minus 1. What is output? Same, 1 minus 1 plus 1 minus 1 plus 1 minus 1. So that is a without shift it is coming. Keep in your mind, it is only one is very important. Whenever you are going to draw the waveform, it is okay. How it is happen? Because I'm going to connect it to the source. I'm going to connect it to the source. So to source to the V plus. So same okay value. So here is a plus means plus. That means what is that one? I'm not telling about output voltage. I'm telling about the phase shift. Does it is any phase shift? No phase shift. What about inverting mode? I'm going to give the source to the inverting mode. Okay, here is a plus 1, minus 1, plus 1, minus 1. What about here? First starting with the plus. So what about output? Minus 1. Okay, so this is about the block diagram and working of the op amp. Okay, then next one is the ideal and practical characteristics. Ideal characteristics means I am sitting on the meditations. So I am not talking, I am not doing any exercise, I am sitting on that ideally. My gain is more, my efficiency is more. Ideal transformer also efficiency. Everywhere ideal is the efficiency is more. Practically I am talking, practically I am walking, I will go to speaking with that others. So making conversations, my efficiency is reduced, my energy is reduced. That is a differentiation. Okay, so input resistance or impedance wise, if I have say it is infinity, it is a mega ohm practically. Output resistance is 0, but here is the output rate is not a 0 in order of the hundreds. So why output is 0? Because input you have see the input V1 and V2 both also equal. So due to the equal of the input, no difference. So no difference means so your output is also you want to get it on that one. So no difference. So input voltage is no difference, output voltage is no difference. So 0 0. So what is our output voltage of the op amp? So output voltage of op amp is equal to V naught dash. V naught dash is equal to gain multiply with the difference of the two input V plus minus V minus, the difference of the two input, that is written here. So bandwidth wise it is infinity, it is not infinity, it is very small values. So gain value it is 7,000 and infinity around the roughly 7,000, it is a lower than that, this is the gain values. So this is about the difference between ideal and the practicals, and a few more remaining things we will going to touch it. Okay, next one, op amp 741. So practically how to do the experiment, you have the experiment is there in practically. So this week you will going to learn about that practical experiment. So that experiment is you will going to achieve with the help of the op amp 741. It is one of the oldest and popular op amp one of the oldest and popular op amp is that ones. Why means they are using it is a high performance. So high performance, it's a monolithic of the amplifiers. So it is applicable on the various places, integrator, differentiator, summing amplifiers. So like it is, how many pins? It has the 8 pin. What is a package? Package, how it is coming the package? Package is a dual inline package. Okay, dual inline package. So it has the power supply plus VCC minus VCC. There are two power supply you will going to apply. Yeah, this is a 741 ARPM. This is 741 ARPM. This is the name is called a package. So DIP package, DIP, the dual inline package. It is like that once. So here is one of the pin starting point is there. That is a pin is indicated as a 1. It is a pin indicated as a 1. So how many pin? 8 pin. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 pins. So where I want to give the plus input. So where I want to give the plus input, where I want to give the minus input. So pin number 3 is a plus, pin number 2 is a minus. So you want to give where I want to get the output, pin number 6 you can take it as an output. So where I want to give this power source plus VCC and minus VCC. So plus VCC you can give that one, pin number 7 you can give the plus VCC, pin number 4 you can give the minus VCC. So whenever you are going to do the practical application, so keep in your mind this is a important about that one. That's why they are simply you can say 2, 3, 4, 7, here 6. So this is the pins only utilized, remaining pins is not utilized, not needed. So remaining pins, what are the remaining pins? Pin number 1 is not needed, pin number 8 is not needed, pin number 5 is not needed. So this is important. And what are the futures? This is the futures about that. Why you want to use 741? What is that one? It's a high, it's a good performance you are seeing. So it is a protected from the short circuit protections. So no frequency compensation is required. It is like that once. So no latch up. Okay. No external frequency compensation is required. So these are the features it has. That's why you go for that is 741. So you high performance and various application you have suitable that ones. So it is oldest as well as popular. That's why. So similarly, pin number 5, okay, 8 pin IC is available, or it has that 14 pin IC also available. If it is open, is a 14 pin IC is coming. Similarly, you have see the data sheet. So what is that one? Data sheets you can see, refer it, and they we will going to use. So like this type of the flat pack type of this type of package. So this type of the package also it is coming. Okay. Yes. So next we'll go for that one total. I mean this unit. I gave the tabulations. What is open loop, closed loop. Next to comparator. Comparator and zero crossing detector. This is two is a combination open loop, and closed loop means segmented trigger. Okay. So what is the difference between closed loop and a segmented trigger? So here is you will going to use a negative feedback. So here you are using the positive feedback. Okay. So what is a open loop and a closed loop? Okay, we'll go ahead on that one. So this is the things good. So open loop and a closed loop. See this is here. This is symbols. I have my mouse arrow is indicating. So this is the open loop. Two input and one output. What about here? Output is connected to that input. Where I can connected in negative terminals. Inverting terminals. Minus is a inverting terminals. Okay, this is a negative resistance. That's why it is called as a feedback resistance. Feedback resistance. So next one. Okay. So where I will going to connect it to my source. The source is a okay. I have to the AC source. Where I am going to connect it. Am I connected for the plus terminal or am I connected to the minus terminal? If I am going to connect it to the plus terminal means non-inverting amplifier. Okay, if I will going to connect my source into the minus terminal means that is called inverting amplifier. That is should be keep in your mind always. So where is your source? Your source is connected to the plus terminal means it is non-inverting. Non-inverting means no phase shift. If I have see that one, so here is a 1 minus 1 I have gave. Here also 1 minus 1 is a waveform is output waveform. 1 and minus 1. So this is my output waveform. Okay, next one is inverting amplifiers. So here I am giving 1 and minus 1. My output is a minus 1 and 1. So here is a 1 means here is minus 1. What is the meaning? It's a phase shift. How much angle of the phase shift? 180-degree angle of the phase shift. So that one you can keep in your mind. This is a one of the point. Non-inverting source and inverting source. So where you are going to give that one. Next one. Okay, in closed loop means same. Okay, I'm going to use as a non-inverting as a source or inverting as a source. I'm going to use. But where I'm going to connect the resistance. So closed loop of that resistance is connected. Output is resistance is connected to the okay minus terminal. That is a fixed one. That's why it is called a negative feedback. Okay, hope you are understand about this one.